All right, guys, today we'll begin multiplying polynomials. So we're going to start off with a little multiplying monomials review, remembering that that's just one term. So if we have x times x, that's a monomial times a monomial. This goes back to our property of exponents. And if they have the same base in case, like the same variable, I can add the exponents. So remember, if I don't see an exponent on a variable, that just means the exponent is 1. Basically saying, how many x's do I have? 2. All right. X times y. Notice they do not have the same base. So when I multiply them, I still just get x, y. They don't have the same base, therefore I can't combine the exponents. All right, negative 2x times 4y. Notice they don't have the same variables, which means I cannot add those exponents, but I can multiply my coefficients. So negative 2 times a positive 4 gives me a negative 8, and I still simply have x, y. All right, x squared y, same difference. X squared times y, they don't have the same basis. One base is x, one base is y. So I just get x squared y. All right, let's get into some exponents with some like bases. X cubed times x to the 7. They have the same base of x. So x is the base. That means I have 3 x's in one case and 7 x's in another case. So if I combine my x's, that means I have 10. So same base, add the exponents. Negative 2x squared times 3y to the 5th. I can multiply my coefficients, which is a negative 2 times a positive 3, which gives me a negative 6. And then they have different bases. I have a base of x and a base of y, which means I can't add the exponents. So I simply get x squared y to the 5th. And lastly, we have negative 7x cubed y squared times 3x squared y to the power 4. I can multiply my coefficients, negative 7 and a positive 3, which gives me a negative 21. I'm looking now and I have some like bases. I have x cubed and x squared. That means I have 3 x's in one case and 2 x's in the other case. I can combine those because they have the same base, add the exponents, and I get x to the power 5. Then I have y squared and y to the 4th. That means they have the same base. They have a base of y, and I have 2 y's here and 4 y's here. I can combine all the y's that I have, and I get 6. All right, so let's go to some little extra complicated ones. Not really complicated, but multiplying a binomial, trinomial, and a polynomial by a monomial. The beautiful thing about this is all it is the distributive property. I'm taking the outside term and multiplying it by all the terms on the inside. So that means I'm distributing x to 3x and x to negative 3. So I'm multiplying x to 3x and positive x to a negative 3. All right, so x times 3x. Multiply my coefficients. I only got a 3. And add my exponent. So I have 2 x's. That means x squared. Well, plus x times a negative 3x. So basically, I'm just multiplying those together, and I get minus 3x. Now, I can't combine these terms because they don't have the same variable or the same exponent. So x times 3x minus 3 is equal to 3x squared minus 3x. Next case, I have my outside term of 2x, and I'm going to multiply it to every term on the inside of my binomial. So I'm distributing 2x to negative 4x and 2x to positive 6xy. So 2x times negative 4x, I'm taking the outside term and I'm multiplying it to every term on the inside. All right, multiply the coefficients of the first set. 2 times negative 4 gives me a negative 8. I have two x's, one x here, one x here. If I combine them, I get two x's. All right, now my second set, 6x times 6xy. Multiply my coefficients, which is 2 times 6, which gives me positive 12. How many x's do I have? I have one x here, one x here, gives me 2. And how many y's? Just 1. Well, multiplying a trinomial by a monomial. That means I'm going to take one term and multiply it to 3. So I'm taking the outside term and I'm multiplying it to the trinomial. So I take negative 3 and I multiply it to positive 7x squared. I take it and I multiply it to negative x. I take it and I multiply it to a positive 4. So negative 3 times 7x squared, negative 3 times negative x, and negative 3 times a positive 4. All right, so negative 3 times 7 gives me a negative 21 x squared. Negative 3 times a negative x gives me a positive 3x. And negative 3 times a positive 4 gives me a negative 12. All right, 2y times negative 6x plus 5y minus 9, meaning I'm taking the outside term and I'm multiplying it to every term on the inside of my trinomial. So I'm taking 2y and I'm multiplying it to a negative 6x. I'm taking 2y and I'm multiplying it to 5y, 2y, and multiplying it to negative 9. So 2y times a negative 6x, positive 2y times a positive 5y, and a positive 2y times a negative 9. All right, my first set, 2y times negative 6x. Multiply the coefficients. Look at my variables, my bases. They're different. That means I cannot add those exponents. So it would just be x, y. All right, my second set, 2y times positive 5y. Multiply my coefficients. Positive 2 times a positive 5. Now my y's, I do have the same base because I have two y's. That means y squared. And I look at my second set, positive 2y times a negative 9. Multiply my coefficients, 2 times a negative 9, y. All right, multiplying a polynomial by a monomial. That means 4 more terms multiplying by that 1. So I'm taking my outside term, 6x, and I'm multiplying it to the polynomial on the inside. 4y squared minus 9y minus y minus 7. Meaning I'm taking the outside term, multiplying it to the first one, multiplying it to the second term, multiplying it to the third term, multiplying it to the fourth term. So I take 6x and I multiply it to 4y squared. I take positive 6x and I multiply it to negative 9y. I take positive 6x and I multiply it to negative y. And I take positive 6x and multiply it to negative 7. All right, so my first set, 6x times 4y squared. multiply the coefficients, 6 times 4, which gives me 24. X and y squared are different bases, so I just bring them down. All right, positive 6x times a negative 9y. Multiply the coefficients, 6 times a negative 9, negative 54. X and y are different bases, so I just bring them down. Positive 6x times a negative y. Multiply my coefficients. Positive 6 times a negative 1. Remember, if it's not a number in front of the variable, that means the coefficient is a 1. That negative makes it a negative 1. So 6 times a negative 1 gives me a negative 6. Different variables, so I just bring them down. Positive 6 times a negative 7, negative 42x. So I'm looking to see if I have any like terms that I can combine. And look at here. Like terms. Because they have the same variables and the same exponents. So 24xy squared, negative 54xy minus 6xy. Remember, same variable, same exponent. So that gives me negative 60 minus 42x. Now my answer is complete because I have absolutely no like terms in my final answer. All right, now last example. Negative 6x squared y times 3xy squared plus 4y cubed minus 2x squared plus 5. All right, so I'm taking the outside term and multiplying it to all the terms on the inside. Very repetitive, guys. So negative 6x squared y times 3xy squared. I'm multiplying the coefficients of the first set. So negative 6 times a positive 3 gives me a negative 18. In the first set, how many x's do I have? 2 x's here, 1 x here. That means the x's are the same base, and I can add those exponents. What about my y's? I have 1 y here and 2 y here. 2 y's here, so I can combine those. Then I go to the next set. Negative 6x squared y times 4y cubed. Multiply the coefficients. Negative 6 times a positive 4. Both terms don't have an x, so I can't combine the x's. I just bring it down. But I have a y and then a y cubed. That means I have 1 y here, 3 y's here. If I combine them, I have 4 y's. So I go to the third. Negative 6x squared y times a negative 2x squared. Multiply my coefficients, which is a negative 2 times a negative 6, gives me a positive 12. How many x's do I have? 2 x's here, 2 x's here. That gives me 4. And how many y's? 1. And lastly, negative 6x squared y times a positive 5. Multiply my coefficients. Negative 6 times a positive 5, negative 30. No x's on the 5 or y's, so I just bring it. And there we go. We have multiplied polynomials by a monomial.